We've always wondered about life out there, but what if we told you that the possibility of more life forms has become surer than ever? It's so powerful it might have just shattered our understanding of the universe. We've all heard about how the new James Webb telescope is kind of like a time machine because it can look back to the early formation of the universe. 6 shocking galaxies have been discovered that defy all explanations. The James Webb telescope has identified 6 galaxies that exist 500 million years after the Big Bang and are up to 10 times bigger than the Milky Way galaxy. Join us as we discuss Michio Kaku breaking his silence on the James Webb telescope's clearest image in history. The shocking discovery of these galaxies is truly remarkable. Building a galaxy is no easy feat. It took the universe over 350 million years to finally form the very first galaxies. They were pretty small and took their sweet time to become the galaxies we know today. But get this, scientists have just discovered 6 ancient galaxies that are breaking all the rules. These galaxies are thought to have formed just 500 million years after the Big Bang, yet they contain populations of tens or even hundreds of billions of stars. American theoretical physicist Michio Kaku is just as puzzled by this groundbreaking discovery, which could change everything we know about the universe. The James Webb Space Telescope, a $10 billion project launched by NASA in December 2021, spotted 6 colossal galaxies, each roughly the same size as our very own Milky Way. These galaxies were formed far too early in the history of our universe. The mass of stars within some cosmic objects is not just a few times larger than our Sun, but several billion times larger. And if that's not enough to make your jaw drop, one of these objects could have a mass of stars up to a whopping 100 billion times larger than our Sun. To put it into perspective, the Milky Way, home to our beloved Sun, has a mass of stars that's a mere 60 billion times that of our Sun. This discovery is truly mind-boggling. As Erica Nelson, one of the scientists who worked on this project, put it, it's bananas. Echoing her sentiments, Michio Kaku believes that huge gaps in our knowledge are about to be addressed with these new findings. This latest discovery feels like a puzzle piece you don't know where to fit. The team of astronomers who spotted these galaxies has dubbed them universe breakers because if they are indeed real, our entire understanding of galaxy formation will need to be revisited. This discovery could call into question some of the basic rules of cosmology, so get ready for some exciting new revelations about the cosmos. Have you ever wondered how the universe, which was once a minuscule fraction of an inch across, expanded to its colossal size today? The widely accepted Big Bang model tells us that the universe was born as a blazingly hot and dense point over 13.7 billion years ago. But what happened next to shape the universe into what it is now? Imagine the universe as a baby born from a single point and expanding at an incredible rate during its first growth spurt, doubling in size over 90 times. As it grew, matter formed, and the universe cooled. Then, the universe experienced a magical moment called recombination, where electrons combined with nuclei to form atoms, and the universe became transparent. After recombination came the Dark Ages, a period of darkness before stars and galaxies emerged. Between 150 and 400 million years later, the cosmos started to come out of this darkness during a period known as reunitation. Fast forward 9 billion years after the Big Bang, and our solar system sprang to life. However, these new galaxies appear to be roughly 13.5 billion years old, meaning they began forming somewhere around the Dark Ages. The galaxies are so large that they conflict with 99.9% of cosmological models that scientists have carefully developed. This indicates that either the models need to be changed, or the scientific theory of galaxy formation needs to be completely re-evaluated. The discovery of such large galaxies so soon after the Big Bang raises the possibility that the Dark Ages weren't as dark as we thought and that star formation may have begun far sooner than previously believed. Thanks to the hard work of scientists, we now know that the Dark Ages lasted from about 380,000 to 150 million years after the Big Bang, and the first stars began forming around 180 million years later, marking the end of the Dark Ages. For the universe to exist as it does today, hundreds of thousands of new stars would need to be created each year by these galaxies. There's a lot at stake, including our entire understanding of this complex cosmos we call home. Before this discovery, the most distant galaxy ever discovered by Hubble was GN Z11, but we'll circle back to that in a moment. For now, Webb's discoveries could fundamentally change our understanding of cosmology and challenge everything we thought we knew. Maybe more studies of the Milky Way already hinted at how soon stars came into being after the Big Bang. Perhaps the discovery of these galaxies was just a matter of time. Speaking of the Milky Way, this discovery will surprise you. Scientists have just revealed the precise age of our galaxy, and the results are shocking. According to a study published in Nature, parts of the Milky Way formed just 800 million years after the Big Bang. Using a survey of almost 250,000 stars, astronomers clocked the development of the Milky Way, splitting the spiral disk into two populations, the younger inner disk, which includes our Sun, and the older, thicker disk that extends further out. The thick disk likely started forming around 13 billion years ago, while the intergalactic halo formed about 2 billion years later. But that's not all. The inner halo came into existence after the Milky Way merged with another dwarf galaxy, Gaia Enceladus, between 8 and 11 billion years ago. While this discovery sheds light on the formation of our galaxy, scientists wish the 6 new galaxies didn't defy all logic. Let's break down what we know about these enigmas. These newly discovered galaxies are more puzzling than we imagined. Their density of matter is so high that it's making cosmologists break out in a cold sweat. The amount of normal matter in the galaxies also conflicts with the amount of dark matter in their halos, akin to trying to fit a square peg in a round hole. To make matters worse, the research team has scoured their work for errors, but so far, their data and interpretations hold up. The idea of rewriting our history books is daunting, and researchers hope for human error rather than accepting how far off the mark our knowledge may be. Most of these celestial objects appear to be galaxies, but some might be gigantic quasars or supermassive black holes. If these objects are indeed supermassive black holes, it challenges current theories about the early formation of the universe. Supermassive black holes are already known to exist at the centers of galaxies, but their formation so early in cosmic history complicates our understanding. Before this, the JWST and Hubble discovered something older than we ever imagined, galaxies like Glass, Z13 and GN, Z11, which are ancient beyond belief. In 2022, the JWST found the oldest galaxy ever seen, Glass, Z13, which dates back to just 300 million years after the Big Bang. This discovery is astonishing, and it may rewrite the opening chapters of cosmic history. Despite its age, Glass, Z13 has a mass exceeding 1 billion suns, though it's much smaller than the Milky Way. Meanwhile, GN, Z11, discovered by Hubble, is another ancient galaxy, formed about 400 million years after the Big Bang. GN, Z11 is 25 times smaller than the Milky Way but is growing rapidly, forming stars at a rate 20 times greater than our own galaxy. These findings offer us new clues about the early universe and give us a sneak peek into the secrets that lie ahead. The JWST is a cutting-edge instrument designed to study these distant and earliest galaxies using infrared technology. Infrared is ideal for detecting light that has traveled billions of years, stretched into longer wavelengths by the expansion of space-time. This is known as redshift, where light from distant galaxies appears redder because the space between us and the galaxy is expanding. By studying redshift, astronomers can peer back in time to the early days of the universe. JWST is specifically designed for this, allowing us to glimpse a universe that was previously impossible to observe. But that's not all. The JADE survey has confirmed estimates for 4 more galaxies, including one with a redshift of 13.2, which appeared just 320 million years after the Big Bang. The race to explore the early universe is in full swing, and the JWST is leading the charge. There's no telling what groundbreaking discoveries are still to come, but the universe never fails to amaze.